it. I clicked the button. Fingers crossed. Hee hee ha ha.
Now we're supposed to roast Connor about having nothing on his walls.
I moved where my office was in the house, so it's bare bones right now. Yeah.
It is a completely blank white wall.
It's as generic as you could get, possibly.
Yeah.
Yes.
Half insane asylum kind of thing.
Yeah.
Like,
Mine isn't even mine. This is my fiance's, and there's like this weird big trophy in the background.
Looks good though.
Yes, but I don't want people to think it's like from Pee Wee, T-ball or something when I was a kid that I'm just still storing in the back end.
It's your little league trophy for sure.
Yeah, exactly. Everyone's a winner.
I dig it. Well, I'll admit, I think we hit the go live button just a little bit early before the usual start top of the hour, because we thought we were just already bantering. We were already goofing off and having some fun, and then we would just show it to the world. But
before we get started, can you explain to the world, John, why you have two watches?
Oh my god, dude, there are so many YouTube comments about this lately. They're like, how come bro's wearing two watches? One of them is just like a Whoop fitness band, and the other is a
I've seen that combination, John, before. Yeah. A lot of people wearing Whoop and then a watch too.
I will say the Whoop watch makes a lot more sense than Whoop watch. Like if you're starting to go up the arm,
put it on two.
It's a little. It kind of reminds me like in high school when people wore like all these bands, rubber bands, all the way up their arm.
The other is the Pebble, which is my absolute favorite smartwatch that went on a little bit of a hiatus because I think Fitbit bought them, and then Google had Fitbit, and then some way somehow. But they came back to life. It's like a sweet open source hackable watch. You can SSH into it. It runs its own thing. But yeah, I can't wear two on one arm. That would look dumb.
Why would you want to SSH into a watch? Like there's some cool tech things that I'm like, hey, that's cool. But there's also why would you want to SSH into the watch?
You can make your own little watch face. You can program and design your own. It's got a whole SDK. It's totally a nerd toy, but I just like it. That's it. That's all.
I respect it. I would have one that's like Arc Raiders right now, just in the background.
Just playing on your watch.
Just playing nonstop. I'm in meetings just.
I felt bad because I was like, I can get the white one, which is in stock, and they had available as they're coming back to life, but they didn't have the black one quite yet. So I'm like, well, I guess I'll do a white on one arm and then black on the other, but I don't know if that's going to look stupid or dumb. And I asked my lovely, beautiful wife, who said no, that would look stupid and dumb. And then when I finally got it, she's like, actually, you know what? It's not that bad. I actually enjoy seeing you something other than pitch black. So totally cool.
Got to respect John's drip at all times.
It's a little yin yang. I thought it was cool.
I respect it. And then Connor's over here looking profesh as can be.
I have not a smartwatch. My dad gave me this watch. It's a Tag Heuer from the year 2000 or something like that. So I guess antique, but
it looks good though.
I like it. Yeah, I like it. He won it at his. He's a salesman. So yeah,
I have a watch. I like wearing watches, but the problem is I don't know how to do it with the Whoop right now. So it's whenever I have a nice event, I'll take the Whoop off because I'll just put on a watch then, because if I'm wearing something like a Whoop at a nice event, I'm not really tracking my heart rate there. There's nothing for me to be tracking at a nice event that is worthy enough.
I wish the Whoops don't display anything, right? That's the whole shit.
No, there is no screen. Yeah, it's just its own thing.
I almost wish they would do a thing where it's on the metal. It's it would tell the time there. Just very, very small, but that would be helpful.
I saw in chat someone, hey, get one of the Aura rings or something. And I know a couple people that have one of those, but I'm going to nerd out again. The Pebble is coming out with their own Pebble ring, which is literally just going to be a physical ring with a little microphone button. So you can talk and record your voice in the moment, and like super Star Trek Spock, like beam me up, Scotty, and you'll send whatever audio or dialogue line that you just sent to your phone, and it can be routed wherever, or do whatever to store a note or talk to Claude or whatever the heck you want to do. So I'm getting hyped up about that. I'm stoked for the Pebble Ring.
Are you going to do the Pebble Ring, ask Claude a question, then retrieve answer on watch?
That'd be pretty cool. I think it would look super nerdy, super dumb, and super dorky, but I think it'd be cool.
That would be actually kind of sick. Not gonna lie.
Yeah. Well, Connor, have you fallen down the AI rabbit hole? I feel like both Johnny and I were going to be super pilled, but we don't need to dive into it now.
I'm not as pilled as some people, like John and Max.
Isn't Max more so than me, I think?
Yes, I think Max is like super pilled. Like you can't get more pilled than Max. And then I would say you have John, and then you have like me. And I'm curious where Connor's at in the pilled.
I don't know like what the exact category I'd put myself in, but it's obvious that these have, these AI tools and models and whatnot have very good use cases, and they're very good. Like, especially if you take a look at how far they've come. I'm just not someone who's really into like, vibe coding or, I'm just going to press this, and it's going to generate a bunch of, amazing, perfect code, which I think there's probably some people that expect that. Maybe that's what I would say. The more AI pilled folks like, I just, turn my brain off. And so I'm not one of those people. I'm more someone who sees the value in them. I think there's two ends of the spectrum. Someone that's like, AI is, I don't need to know anything anymore. And then people say AI is dumb. I think both probably, at this point in time, at least are wrong, but I do see the benefit of it. But I'm not someone who's a vibe coder or anything like that.
So I would say
asking a real question before we started the pod. I was like, oh shoot, we're going into a real answer right now.
So what I'm hearing is Connor is less pilled than me. And he also likes the pain of real programming and debugging and seeing builds fail, which I respect because I also too like that. But sounds like lower than me is the answer.
And it's improving every day. The problem is as well, there's so much inundation on, Twitter and everything. It's like so hard to keep up with what's the latest, what's the greatest. But as time goes on, like I said, I've definitely, when it first all started, like most people, I was like, nah, this is dumb, but it obviously has some meat to it.
Yeah. Yep.
All right. Top of the hour, y'all, 6 o'clock. Last time we hung out with Max, we were doing like a normal, like regular day kind of thing, but we figured we'd keep things pretty casual, pretty chill, pretty relaxed as we tend to. For anybody tuning in, look, we wanted to get together again for the Payload podcast, which was a sweet idea that Johnny and I came up with to really have an excuse to keep hanging out with each other. Because we would get together at some events and we just really miss the equivalent John. Like, you know what I mean? It was just one
John squared.
Like we couldn't be without each other.
Yeah, exactly.
But
if we did schedule time, we always got too busy and we never actually made anything happen.
On that note, how are you guys doing? How was your day? How was like 6 p.m. Eastern, right? What are you guys up to? I'm exhausted. I'm tired.
Yeah, I would say same, but tomorrow's Friday. So looking forward to that. It's been a long week, but it's finally a little sunnier and warmer here in South Carolina, which is nice. It's no longer like freezing and raining. So
you did it. You went straight for the immediate docks again, Johnny.
Well, I'm South Carolina is a whole state.
True.
It's like, come find me. It's like it's so big. What about you, Connor? How's your day been?
Been going well. I started.
I'm sorry. I didn't mean to start our actual thing as how was your day going? Forgive me. But yes, no. Connor, you got a new job, right?
Yes, I did. So just been cycling into that. Weather's been better here too. I'm not going to give any indication to where I live. But no, been going well. Excited to chat with you all. It's been a while. I think the last time we were all together was probably Black Hat.
Yep.
So yeah, been going well. New job going well as well.
Can you talk about it? Can you say? I didn't want to be. I didn't.
Yeah.
Like
I can. Yeah. So I went back. I originally, before the job I previously had, was in CrowdStrike. So I'm back in CrowdStrike. I'm in a new team in sensor engineering under the new CTIO, Alex Ionescu, which is the Chief Technology Innovation Officer. And basically, when I was originally in CrowdStrike, I was more doing feature development for the Windows sensor and kernel and user, features that come in, all the typical stuff anyone in this space, knows and loves. What I'm really interested about my new role is it's more on the innovation side. So what are things that we can do better, as an example, outright than just here's this new feature, things such as that. But it's only my second day, so how it goes, I'm interested to see. But just with my initial conversations and first few hours, I guess you could say there, I've really been enjoying it a lot. And so yeah.
Very nice. So for those that don't know you, Connor, can you give us a little bit of a background? I mean, I've known you. Fun fact: Connor and I went to college together, so I've known him for a very long time. John, I don't know if you know that. Did you even know that?
No, I had no idea.
That's how Connor and I know each other. So Connor and I went to college together, and then we both graduated. And Connor got like 4 times like smarter than me and just excelled because he was like doing all this red team exploit development, and I was just writing like KQL queries. So he has a really cool background. So Connor, for those that don't know you, tell us who Connor is. Who the Connor is.
I don't know about the Connor, but as Johnny said, we went to college together.
Were you guys roomies? Were you like hanging?
We
were you
weren't
all in the same dorm? Oh,
no, we weren't.
No.
We're from very small place, and so this was a commuter campus.
Roger that.
Yeah, so I lived in the same place where I went to school. And so
it wasn't a community college, guys. It was an actual university.
Yeah, it was a university.
Yeah,
real school.
But exactly. Yeah. We went to school together. We participated in the collegiate cyber defense competition together as well, CCDC, at the Missouri level. Oh, there it goes, Docs. And,
I knew it was going to happen.
Yeah, and at the regional level as well. So that's how we originally got to know each other. It's how both of us really got started in security. And I've always been someone who's interested in not just the how, but the why. So I've always just been curious, I think, as most people are in security. And so where that leads some people, at least like myself, is you don't just want to know, okay, I type in this command, I get this result. It's like, okay, when I type that in, what actually happens under the hood? And eventually you're peeling back layers and layers and layers, and you go lower level, lower level, lower level. And so eventually you get interested in low-level concepts like operating systems. How do they work? How does this program work? How do CPUs interact with memory? When I boot my operating system, how does that actually work? And naturally that pulled me into the kind of binary exploitation scene. And so I got my kicks, I guess you could say, starting in offensive security in the exploit development space, not in a professional setting or in a job or anything. And I kind of knew I wanted to do something related to exploitation, which for those who don't know, binary exploitation is basically how do you take advantage of binaries, operating systems, exploits, targets in terms of memory corruption and things such as that. And so eventually started just getting interested in memory corruption, exploitation, everything like that. But it's very hard to find jobs entry level for that position. People want more experienced folks and whatnot. So I said to myself, all right, well, I'll go in the red teaming space. I'll go in penetration testing, red teaming, just to get my foot in the door. Then eventually I'll go into exploitation. And that never really panned out because I never actually made it into an exploitation job because my interests slowly but surely started changing. So eventually I ended up working in CrowdStrike in the red team there. And then after I worked in CrowdStrike in the red team, someone who I'm very close to in CrowdStrike was leaving. And they said, hey, you should move over into engineering. You know, all the cool kind of kernel development, operating systems internals, all that stuff is present in that role. And so eventually I went into engineering, not knowing anything about development or anything like that. Got acquainted with it, started improving more and more. But my heart's always been obviously in exploitation and reverse engineering and all of that fun stuff. So that's really how I got started.
Not to cut you off, I'll never forget. I got to tell a cool story about college. So I'll never forget. We used to have our classes were weird, and this maybe people are used to this, but we used to have 2-hour blocks of courses or of class. So it's like specifically for our cyber courses. And I'll never forget that we had one that was like, correct me if I'm wrong, Connor, I think it was like 10 to 12 was one of them. It was like in the morning. And I would come in and Connor's over there on a Windows 7 box, just like going ham, trying to figure out all these different things while I'm trying to wrap my head around what's going on in class. So he's been into it for a long, long time. And so it's been really, really cool because anytime I've ever had questions about like systems programming or reverse engineering or whatever it is, Connor's always been one of the first people I reached out to just because of his, I mean, it was just something that kind of hit you and you just kind of ran with it. And it was really sick. I mean, it was, even in college, you were just teaching stuff that was way above my head. It was so cool. Looking
back, all that stuff, like, is so, remedial, as you said, Windows 7, like now I'm like, oh, who would care about doing this? But binary exploitation is one of those things where it's very hard to hit the ground running with the current state of it. You really have to understand the fundamentals. So even if that means old operating systems, 32-bit things, which necessarily aren't in production today. And so, yeah, it's just always been very addicting to me. And I think it comes back again to that you want to be able to fully understand something, which is probably also why when we talked about AI earlier, why I'm probably not as AI pilled, because it's hard for me to give up that control where it's like I want to understand every single thing that's happening all the time. Definitely, no doubt. But
I think that's a great way to put it, because to be honest, I think that's one of my struggles with AI. Not that I don't see that like there's benefit, but like I have to know what's going on under the hood. I have to know what's being written, like what the flow of the code is or whatever it is. I just have to know. And I can't just like ask it and be like, how does this thing work? Because I have to go figure it out and validate that it's not wrong. And so I think what you just said, I think that really hits the nail on the head. It's just a little bit of control of like knowing what's there.
Exactly. And the same thing, to give an analogy that I use when I talk to people, there are people out there who are afraid of flying, right? Because, you're in a situation that you can't control. People say, I'd rather drive because driving statistically is probably more dangerous than flying. Like if you look at the actual statistics. But that's hard to tell someone because it's about control. When you're driving the car, you're in control for the most part. Whereas when you're flying, you're totally giving up control to somebody else. I think it's the exact same thing, at least I view with AI. It's hard to give up that control. It's not to say you can't go back and review the code and anything like that, but I have a hard time because I don't want to foster the mindset of I can ask AI to do something for me and my expected outcome works. And that's like my minimum bar. And then I just, don't look at it again. Because, when you're in and you're doing proper systems development, programming and whatnot, there's debugging issues. There's, things like that where if you don't have a full understanding. So for me, I'm still trying to find that balance in terms of AI. How much control do I give up? And how much, do I let AI do things for me? And I think as things get better with the models and whatnot, they already are. It's probably easier to give up that control. But yeah, TBD.
And John, you met Connor in a class, didn't you? Am I remembering that correctly?
Yeah. So I was scrolling through your blog just a bit to add some more little eye candy and visuals here for us. But the funniest thing was like when I was going through ye ol' OSCP and ye ol' OSCE and the OG original OSCE before the OSCE 3 things, lots of acronyms and letters and numbers. I apologize. But like, I remember seeing Connor's blogs online and be like, oh dang, this guy's super smart, he's a wizard, he's gone through like a whole lot of the stuff to kind of go through those material. And then I think he was prepping across the internet airwaves. Like this was before I think I knew personally. We might have ran into each other like Wild West Hacking Fest. I remember like, hey, I like your talk, you were cool, and we did like a weird it was a fanboy moment for me, I'll say. I don't know about him.
No, absolutely.
I was like, oh shoot, he's prepping for OSEE, the offensive security exploitation expert, at the same time that I was. And then we realized like, oh dang, we're in like the exact same class at Black Hat. So the funny story was that like we were, I think Connor sat in the row in front of me. Caleb, another buddy of mine, was beside me, and we were both in there finally after the however many years it was delayed because of the COVID timeline. But we kind of like got to hang out and got together for like some of the projects or the evening homework that they give us, as like they're the extra miles or exercises to get a little bit smart. And I remember there was one I felt awful because I was at the end of my rope. I fell asleep. I couldn't keep cruising, but Connor and Caleb were beaten up. Yeah, there it is. And you got the coin. You got the hell yeah, super
on my desk. How can I not?
But I knew from then Connor is totally a genius and a wizard, but super genuinely, literally low level. Like all about binary exploitation, reverse engineering, kernel control flow guard, etc. So you've got some super sweet stuff lately. And I didn't know if you had any stuff that you wanted to share or showcase, but I mean, as always, you're just doing wizard witchcraft right now.
I don't know about wizard witchcraft, but yeah, no, it was great. And Black Hat. I'm glad you said Caleb because I'm like, I didn't want to, I didn't want to bring anyone's name up that didn't want to be mentioned publicly. But yeah, we had a great time in class. We were, for those who don't know too, John probably does a disservice to himself even because he makes it seem like, oh, it's just this after homework. I can go back in the Discord and see all of our messages at like 3:30, 4 in the morning, going through trying to do these extra mile exercises to get all this swag and all this stuff like that. And this course is crazy for those who don't know. Now I think it's calmed down in terms of getting into the course, but literally back then it was only taught at Black Hat, and people, including myself, would literally write scripts to scrape the Black Hat website to send you a text for when the course went live because it normally sold out in about 20 to 30 minutes in a lot of instances because it just was like only taught once a year. But as far as stuff that I've been doing now, yeah, most of the stuff on my blog is related to exploitation, but really in the last probably year and a half, I've just been more trying to fill in some gaps in terms of documentation for things that I see out in the public, especially Windows systems now are virtualized. For those who don't know, you buy a Windows 11 machine, secured core PC, for lack of a better term, you're running in a VM. And so there's not a whole lot of research on those topics. And then as well as that, ARM64 on Windows has really improved significantly in the last. Yep, go ahead.
Yeah, there's two things I wanted to see if you wouldn't mind diving into. I think you bringing up the fact that the operating system on Windows for newer builds at least are broken up into this thing called Hyper-V, and there's virtualization applied, all that other stuff. I think that's news to a lot of people. Could you dive into that a little bit more? If I did it, I'd butcher it. But at as high level as you can from a low level perspective, could you kind of dive into what that maybe means and give some people some context around that?
Yeah, I'm happy if you want to. I'm really partial to diagrams if you want me to just I have this Surface Pen that I use.
Please. The visualization. Yeah. Are you able to share your screen?
I don't know how to. I don't know how to read. I just know how to look at pictures.
All right, so I'm going to share my entire. So first, you'll see an IDA thing for something that I'll share later. I'm trying to make sure I'm not giving it.
Let them cook. Let them cook, guys. Let them cook.
I will turn on Zoom it. I don't know. Okay, yeah. Gotcha. So this is a sysinternals tool that you can, draw around on, or even like add in text or, other random stuff like that.
Good game.
Yeah. So basically, to what Johnny was saying is that you have an operating system. Let's say this is Win.
By the way, shout out Connor for still having to not. He hasn't activated his Windows license. It looks like, running that free version on the bottom right.
Thanks.
Evo.
So you have your traditional kernel, let's say kernel, and then you have this barrier that goes across, and then you have user mode. And let's say this is just filled in by random components. So you have a user mode and a kernel mode. And so from an exploitation and just offensive tradecraft background and whatnot, what starts happening over time is more mitigations start going into user mode. Tons of mitigations are in user mode for user mode exploits. And so folks in the exploit scene, the cost of developing exploits and whatnot gets a lot higher. But kernel was never at par. So if anyone's familiar with a mitigation like ASLR, address space layout randomization, where memory addresses are randomized, that didn't come to the kernel until way later. If you're familiar with data execution prevention or DEP, a very old legacy mitigation that's been around since, I think, optional in XP even, all of the kernel pool memory, so the memory in kernel mode used for, kind of like the heap in user mode, was executable even through Windows 7. So kernel was always left far and far behind. And with that, adversaries start taking advantage of the kernel. Well, kernel is king. If you have access to the kernel, there's no more lower level that you can go. This is the lowest level that you can absolutely go. You can do anything on the system. You can install rootkits, you can corrupt the OS, you can install backdoors, you can do all this stuff, right? Microsoft, people can hate on them, love them, have always actually taken a lead when it comes to research. They have the MSRC, which, everyone can always do better. But they award bug bounties, they collaborate with researchers. And so they're up to date, they're privy to what the state of the tradecraft is. And with all of this kernel mode shenanigans going on, basically Windows is now broken out like this. Instead of just having the raw OS like this, and we have our kernel mode, like we talked about, kernel, we now have a lower level, which is hypervisor.
We're sending DMs back and forth like Connor's cooking right now. He's cooking.
No. So we have hypervisor. And with that, the hypervisor is an even lower level than the kernel. And so this isn't the full picture that I'm drawing. I'm just setting it up for now. So we have the hypervisor, which is lower level than the kernel. And because of that, we can break the operating system out like we would break VMs out. So take, for instance, this is all of the physical memory on your machine. So this is your RAM. We now can break out the operating system into two, what we would call VTLs. VTL0, VTL1. VTL0 and VTL1 are the only implemented VTLs, but it goes all the way up to 15 from a zero index. So there's 16 total VTLs that can be used at any given point. What is a VTL? I'm bringing I'm bringing up all these random acronyms. VTL, like all this stuff. What does this all mean? This makes no sense. VTL refers to virtual trust level. A virtual trust level is basically an abstraction of a VM. And what I mean by that, it's a virtual machine in the sense of this is an isolated region of physical memory. And this is an isolated region of physical memory. If anyone knows anything about virtualization technologies, when you go to create a VM in like a type 1 hypervisor like Hyper-V, your VM gets put in what's called a partition. It's called a child partition, and it's an isolated region of memory. This is how you prevent one VM from accessing the memory of another VM. So the spec of the hypervisor on x86 processors, as an example, and ARM processors, allow you to do this. So Windows actually takes advantage of this. So the traditional operating system, so when you boot your machine up and you're logging in, you're accessing your desktop and all of that, that's running in this VTL0 over here. So this contains your traditional NT kernel. And this contains NTDLL, your kernel 32. etc. Let's draw this partition going through. So we have user mode up here, and we have kernel mode down here. But now we have something called VTL1. We have a special region. So this is our second VM, so to speak. And it has something called the secure kernel. Secure kernel. And it has something called IUM, which is isolated user mode, which is user mode in VTL1. And so what happens is, let's say you're an attacker. An attacker only has access to VTL0 just in the same way that if you're in one VM, you cannot access a different VM, right? Like if I'm in one VM, I can't just, do a process injection and do a process running on VM2 because they're in different regions of physical memory, and the hypervisor is the broker. So this is where the magic comes in. It's the hypervisor is the broker between all of this, which is Hyper-V. So let's say I'm an attacker, right? This is my attacker. And I have access to the NT kernel right here. I've done a kernel exploit. I'm at the lowest levels of the operating system or anything like that. This is not the full keys to the kingdom because all of the sensitive resources, so there's descriptors in kernel mode that describe all of the memory that says this region of memory is executable. This region of memory is writable. These regions of memory are, read-only. That's the sensitive parts of the operating system that attackers will look to exploit for rootkits and things such as that. If you want to patch code, code by default is only readable and executable. You have to make it writable somehow. All of that source of truth is now managed by the hypervisor. So even an attacker that goes to access memory here can be intercepted. The hypervisor can go in and actually say, I'm going to intercept this memory access that you're going to perform, and I'm not going to allow you to access that resource. So for brevity's sake, the hypervisor is now the source of truth for memory permissions, for any of this other stuff. And so an attacker just with kernel mode access can't corrupt memory, can't do some of these other things. And for people looking at this diagram, it's like, okay, great, Connie, you've talked all about this VTL0. So what's the point of this secure kernel and all this stuff over here? The secure kernel is what's allowed to configure this VTL right here. So what I mean by that is when the operating system is booting, VTL1 is trusted. The higher you are in a VTL, the more trusted you are, so to speak. You're not more privileged, right? If I'm in kernel mode, I'm in kernel mode. It's just like being in kernel mode on any VM. But I'm more trusted, so to speak. So the secure kernel is allowed to impose its will on VTL0 to say, hey, VTL0, you're only going to be read-only in these regions. You're only going to be executable only in these regions, things such as that nature. So all of the primitives, which have existed before to do things like create dynamic code in the kernel, as an example, are gone because the hypervisor is the source of truth. Hypervisor can crash the machine, as an example, if it sees NT doing something sketchy. The secure kernel is also allowed to receive information about what's going on. There's obviously a communication channel, which resides here, which is one of the things I recently blogged on as well. So your Windows system is a lot more complex, and this has been the case since about 2015 or so. If you're familiar, anyone with the core isolation, probably a lot of gamers have seen that setting before because it messes with a lot of anti-cheats and things such as that. Core isolation has a feature called memory integrity, which can be toggled on and off. That's HVCI, Hypervisor Protected Code Integrity, which is a feature that Hyper-V enables. So that's a long-winded way to say operating system is split out now, and the hypervisor has a lot of control. Now, we're not in a VM in the literal sense as like, someone installs VMware and puts up a VM. There's a lot of enlightenments, optimizations which happen, but basically the spec of the hypervisor of x86 VTX says, memory access in a VM is gated by the hypervisor. That's why we do all of this in the OS today.
You had a couple questions coming in of like, oh, when did Windows shift to this model? But you said 2015, right? 2015.
There's a talk at Black Hat USA 2015 by Matt Miller and Dave Weston, I think it is. They're from Microsoft. And they are the ones who started showing, here's how we're going to be implementing this. I think it was in preview back then. So 2015. Now, if you have a secured cord You can look up on Microsoft's website. If you have a secure core Windows machine, all of this stuff comes on by default for you on secure core PCs is what they call them. And you can toggle some of this stuff on and off manually. But 2015, and I think secure core, I don't want to say, I think maybe 2020 is when those started, but I don't know for sure off the top of my head.
Well, goodness gracious, man. Thank you for diving into that.
Yeah, no worries. Yeah, there's a lot better explanations probably online and whatnot. But yeah, the operating system's broken out like this. What I think is an interesting thing for research is this over here, the secure kernel itself, because the secure kernel is not something that you interface with. It's something that's in the background in this. Think about if you have, a VM running and you have another VM in the background that's like minimized in a tab. You can't interact with it or anything like that. Again, this is a gross oversimplification. It's not a VM in the strict sense, or it is a VM in the strict sense because it's an isolated region of memory. But there's a brokerage communication channel that goes back and forth between VTLs. Because VTL0, like the regular NT kernel, needs to tell the secure kernel, hey, be ready to track this memory because it's important. Secure kernel and NT are in isolated regions of memory. They can't, talk to each other. They don't have access to each other's memory. So there is some communication, which I think is quite interesting. Obviously, there's not a whole lot of research out there on it.
Have you seen any vulnerabilities for that communication bridge between the two, or not really?
Yep, I've seen some vulnerabilities. There's a Black Hat talk from 2021 or 2020. It's by Sarah Marr, who works in Apple now, who was part of MSRC. And he did a talk with Daniel King, I think it was, where they talked about they had an internal fuzzer, which is similar to a public project that I put out after the fact, which basically should be like a public version of that, that allows them to manually invoke the secure kernel. And they found, I think, 2 or 3 vulnerabilities. And they go through and talk about, here's how we found it. Here's the exploitation primitives that we had. Because it's one thing, right, to just write into the secure kernel. Yep. You got to have a whole primitive set up to say, like, okay, now that I can write, how do I actually do something that can result in code execution or memory disclosure or things such as that?
And this is potentially a dumb question, but let's say you're on a Windows machine with all this set up this way,
yep,
and you create another VM within that.
Yep.
That doesn't go and create its own VTL, correct? That still lives within VTL 0?
Still, yeah, exactly. What happens is this is called the root partition. This is a special partition in Hyper-V. The OS lives in the root partition, and the OS is obviously broken out into VTLs. And so when you create a VM in Hyper-V, that creates a child partition, which is an isolated region of physical memory still, but it's a little bit different than the root partition. The reason why they're delineated is because, again, imagine you had to paravirtualize every single device. And so every single time you access something, you have to go through the hypervisor and go back. That's doing a lot of context switches that hurts performance. So there's what's called enlightenments where the root partition can still directly access some stuff, has some additional things. There's something called the TLFS, which is a specification for Hyper-V, which talks about some of the privileges that a root partition can have and whatnot, or a partition in general. So to avoid all of that, overhead, that's why the delineation is there. I saw a question too. It says, is it a VM in the sense of having nested page tables? That is exactly right. SLAT, second level or second layer address translation, is the magic that makes all this happen. So the hypervisor has, for each VM has what's called a virtual machine control structure, which is specific to x86 and Intel, because the virtual machine control structure basically describes a given VM. And a processor historically could execute in context of user mode or kernel mode. So when you're executing in kernel mode, you're doing all the kernel things. You can access devices, all this stuff. And when you're in user mode, it's obviously higher level. You can make system calls, all that. But now the processor with VMX can execute in context of either a guest or a hypervisor, which is called a root or non-root mode. And with that, every VMCS has a page table pointer for those nested page tables that I saw someone talk about. So yes, that's exactly what's being used here. But there's a special delineation. The physical pages are what's called identity mapped, which I won't get into, but basically they're not really needed for translation. They're just needed for memory permissions, because the page tables describe not only where the memory lives, but or where the memory is mapped, but describes the permissions: readable, writable, executable.
Very nice. Well, thanks for explaining all that. Yeah, whenever you mention that, I think that's news to a lot of people, because I know you and I chat about it sometimes, and you're teaching me all the things and explaining it all to me. And I don't think many people think of the OS, or like when they buy a new Windows machine these days, that this is all at play now.
Yeah, exactly. And I've been doing some research into ARM. Obviously, the thing about, Windows is tries to be modular and portable in a lot of ways. It can't always, because it's an operating system. So hypervisors are one of those things that are very, very, very platform specific, right? It's not like there's actually multiple Hyper-V binaries, depending whether you're running on an AMD processor or an Intel processor, even on the same, instruction set, x86 or x64. And then ARM throws an additional wrench into that too. So it's interesting. I have a blog as well on ARM internals for like how the hypervisor works or anything like that. Yeah, someone says this is a serious rabbit hole. Yeah, you're telling me. And it makes it harder because the hypervisor is a black box for Microsoft. Hyper-V does not ship with what we would call symbols, which basically describe, here are all the function names, here's all the data types.
Am I pulling up the right one, Connor? Is this
Yeah, that goes into it a little bit. That one goes into specific ARM64, and it has some secure kernel at the bottom as well, about how something called pointer authentication works, which is something that I could talk about a little bit too.
I'm sorry, I threw us into another rabbit hole, didn't I?
No. I enjoy talking about this stuff. And so pointer authentication, if anyone is familiar with a Stack Overflow vulnerability, right? Stack Overflow vulnerability, you have like a string copy operation as an example. This is more OS and operating systems, but when you have a function written in C or whatnot, variables get allocated on the stack. And so if you basically exceed the bounds of the stack and you override it, you can start overriding other contents on the stack, which is a data structure in memory that you maybe shouldn't have access to in the first place. It's undefined behavior, very common vulnerability. And there's a bunch of mitigations which exist for this. On x64 and x86 machines, there's something called shadow stack, which is specific to Intel CPUs and AMD as well, which basically there's now an immutable copy of the stack that can only be accessed by hardware or a higher privilege level like the kernel. And with that, you basically can have a known good copy of the stack. So anytime the stack gets corrupted, the traditional stack someone's using, you could just compare and go, hey, something's not right here. But again, as I talked about, a lot of these mitigations, a lot of these features are architecture specific. ARM64 or ARM machines don't have shadow stacks. That's an architecture thing. So what do? They have their own implementation of mitigation, which is called pointer authentication. Basically, what happens is pointers get signed and stored in a register that can't be accessed arbitrarily. And with that, anytime a return operation happens from the stack or whatnot, in the case of Windows, they use it to sign code, but you can also use it to sign data. The signature is validated. And I have some more demos where I can go into this kind of based on that blog. But basically, there's something called a pointer authentication key, which is the signing key. So a return address gets signed every time a new function is executed on Windows for those who have opted into PAC support. And every time a return happens, we compare or we validate the signature. And so if someone's corrupted a return address, as an example, with a different return address, which is a common primitive in Stack Overflows, the signatures won't match. And this is a feature in user mode and kernel mode as well. So I can.
Am I driving us too far? Yeah. What do you think?
No. I have.
While Connor's pulling this up, this is a really cool concept, because what's nice about this is, I believe besides you, Connor, Yarden did a blog on shadow stacks. Am I correct on that, or was Alex?
So Alex and they both did a blog on shadow stacks. So what they did is talk about what's going to be the Windows implementation of CET. And CET is Intel's control flow enforcement technology. Under that, there's two mitigations, main ones: indirect branch tracking, which is not used by Windows because it uses control flow guard, and shadow stack. So they talked a lot about, here's the CET implementation. What I had done about shadow stacks is, like I said, there's a lot of nuance with how kernel mode shadow stacks work. So for a kernel mode attacker, right? In user mode, the user mode shadow stack can be manipulated and whatnot by kernel, and user can't arbitrarily access kernel, so you're fine there. But what happens with an attacker that has kernel mode access? What's the higher privilege boundary to protect against some of the stuff? So what I did is did some reverse engineering on how the shadow stacks work, how they're managed, how the secure kernel and VTL1 protect the shadow stacks as well, which there's some similar functionality for PAC as well, because again, an attacker has access to kernel mode. Who's stopping a kernel? Like, what people have to realize is this. Let's say you have a mitigation in kernel mode that says, here's a list of all of the allowed functions that are allowed. These are the functions that you can call. It's an allow list, right? I'm not saying this mitigation exists, but theoretically, if it exists, here's all the functions that can be called. And you're an attacker. What's an attacker want to do? Obviously, the opposite of that. I want to call functions which are not on that list. Well, you can't do that because it's an allow list. So what do I do as an attacker? Well, first line of thinking is, why don't I just corrupt that list, add my own function in there that I want to call, and then make my own call, right? Who's stopping me? Well, if I'm in user mode and the list is in kernel mode, that's fine. Because I'm a user mode attacker, I can't access kernel mode without a vulnerability. But if I'm a kernel mode attacker and the list of functions that is being protected is also in kernel mode, what is it's a chicken and egg situation. What's stopping me from corrupting that list and then doing my thing? This, again, where it comes in that the hypervisor is being used to break out the operating system, because we do have a higher privilege boundary now to say, although you can see that list, you can read it, when you go to corrupt it, actually, we're going to prevent you. And the hypervisor can unmap the page. The hypervisor could say, actually, you can't even access this page to begin with. That's not a page that you're even allowed to access. Memory page being memory address. So that's what I was more focused on in that blog. And I gave a talk at Black Hat 2025 in USA on both kernel CFG and CET, which I talked about in my blog.
Was ARM forced to implement PAC because there was shadow stacks on x64? Or like, was that a requirement by Windows because that was already available in another architecture and they had to come up with an equivalent?
I actually don't know the reason for it. These are just all architecture things that each vendor has to make their own determination of what's the best way to go about this. Because there are some consequences to using shadow stacks as well. It's not a free operation by any means. You have to have certain CPUs to use it as an example too, which same thing on ARM, you need certain CPUs for PAC. But it just comes down to, a vendor saying, here's the best way that we think about this. What are the established practices that are out there as well? Another example is Microsoft tried to implement a shadow stack in software a while ago. It was called Return Flow Guard. It got completely deprecated, and they waited for CET to come out shadow stack because they found the internal red team found a bunch of bypasses to it. So the same thing could be said. Microsoft, there's a really good talk out there. I think it was at Offensive Con, maybe 2021. It's by Joe Bialik. He works in Microsoft in the Morse team now, I think, which is the Microsoft Offensive Research Security Engineering team. He talks about the mitigation strategy at Microsoft. So again, Microsoft is not necessarily a CPU vendor, but he talks about, from an OS perspective, all the design decisions that go into how you design a mitigation, why we chose to do this, why we didn't choose to do that. So in the same vein, silicon vendors are also doing this. What's the best way to do this? What's the historic, roadmap, I guess you could say, for lack of a return, or history surrounding these types of mitigations? I don't know if one is better than the other per se. There's a little more software involvement probably in shadow stacks. Well, there's software involvement in both of them. But yeah, ARM is just a very interesting architecture for me, especially on Windows systems, because most people that use ARM, it's for IoT devices, it's for Linux, Mac, the Apple Silicon runs, I think, on ARM architectures. And so it's interesting, these Windows, it's historically always been x64, x86. But now, as an example, if you go online and try to buy a Surface laptop, you really can't find an X64 model unless you're a business, buying them for business. A lot of them are just ARM because it's what they're shipping, especially with NPUs and all of this stuff. So it's really interesting, and it's a very green field, I think, for Windows.
I will say Connor got me ARM pilled because I also have a new Surface laptop that is ARM.
I'm not AI pilled, but I am ARM pilled. Definitely.
Yeah, exactly. And the reason why I got an ARM machine was so that I could learn how to reverse engineer ARM better and do all those different things. But it was really Connor at the end of the day, because when he came out with his pack blog, I was like, what is this? And how do I look into this? And the answer is look into ARM. And it's interesting, the ARM architecture. One other question before we kind of dive into if you have some demos for some of the pack stuff. And it's a potentially dumb question, but just for my small brain here, if there is a CPU mitigation feature that's kind of built out, does Windows have to turn on that feature for the OS, or does it already embed into, I guess, how code flows and things like that? Does that make sense?
Yep. Normally when there's a mitigation, almost all of the time there has to be some level of software involvement. So let me give you both an example. So let's say we have multi-processor systems today, and every thread is associated with a stack. So every thread has a region of memory called the stack. Well, if you have a stack, you now have a shadow stack with the shadow stack mitigation, right? Processors, generally speaking, there's such things as hyper-threading, but let's say in a very easy example, there's just one thread on a processor at any given time. Well, that thread isn't going to hog the CPU the whole time. It's going to, say, hey, I need to go run, then it's going to go leave, right? That's what's called a context switch, where we context switch from one thread to another. Well, if I have a shadow stack associated with a thread and I'm leaving the processor, that thread has to maintain state of where is the shadow stack for when I am allowed to go on the processor again, just as an example. So just right there, you have to have some level of software involvement to say, okay, the next thing we need to track in that context structure that we're tracing across context switches is the shadow stack. So that's one example of why software would have to be involved. A lot of these mitigations as well either involve compile time support, or they involve enabling it through what's called MSRs. And MSR is a model-specific register on x86, but there's also system registers on ARM. You could think of these as feature masks for a lot of these registers that denote, here are the list of features which are enabled. And you have to turn some of them on or off as an example. So there's always software level involvement. I think what's cool about operating systems vendors is there's probably a lot of collaboration, right? Hey, Intel, you guys are developing this hardware mitigation, but we're the software vendors, the OS vendors that are going to have to implement it. Let's work together to figure out what the best way to go about it is. Microsoft and other OS vendors obviously work a lot of the times with these silicon providers. So definitely there's software involvement with these. And you also have to handle cases where, you have a newer version of the OS that supports CET or what have you, but you're running on an older processor. How do you make sure you don't inadvertently enable something, which even if, a lot of the times that's undefined behavior, so you don't want to engage in that.
Yeah. Dude, that's a lot of great information. We really appreciate it. John, what do you think? Do you think we got time for a little demo action before we end?
I think all my friends are smarter than me.
That's how I feel as well.
Some of it goes way over my head. I feel like I catch a couple of them. I feel like I was with it up until oh shoot, yeah, I'm off the cliff. But thank you so much for letting us hang out, Connor. But yeah, if you do have any more show and tell, if you're willing to do a little bit of demos.
I don't have an exploit demo or anything, but I have some I have IDA open.
Good enough. That's all.
Check the I'll show the debugger too. Let me increase the
font. Let him cook.
I don't think I have your screen share quite yet, but when
I'm going to increase the font here just real quickly, and you can tell me if I need to increase.
Johnny, what are we doing here? We started the first season, episode 2. We got Connor in here, and you showed up everybody. Max, no comparison.
Let's see if this goes through. I like Max. Okay, so basically this is a secure kernel. Actually, I don't want to share this one yet, but I will show the.
Right. He's cooking.
Let me just share the entire screen. That's going to make it easier, and hopefully I don't get any notifications or anything.
We're gonna have Max come on here and be like, Max, show us how AI can explain all this. Now we should do AI Max versus Connor on the OS low level and see what happens.
No. So basically, this is the NT kernel. So anytime a process is starting in Windows, this is the kernel binary, and this is in a function, as you can see down here, PSP allocate process. So for those who aren't familiar with like Windows nomenclature, PS is like the process library. And then you have P. This P right here denotes private. So this is a private function. It's not exported. It's for internal usage. It's not documented, which as a security researcher, undocumented stuff is your bread and butter. So effectively, a process is represented in the executive of the kernel, which is the higher level part of the kernel that's responsible for object management, processes, threads, that kind of thing. Or I should say the objects representing those. And what happens is you have this field here called mitigation flags, and there's 3 of them. There's mitigation flags 2, and mitigation flags 3. So I will open up the local kernel debugger here. So this is a kernel debugger which is running locally on my system, and I'll zoom in a bit in the text. So we can dump out eProcess mitigation flags. So the process object maintains a list of all the mitigations which are enabled. So in Windows, if you go to the exploit protection UI in the security center, you'll see a bunch of mitigations that you can enable. When you toggle those on, the process knows which mitigations you tried to enable through this. So Winbag has some really powerful queries that you can do. So I can use link syntax to basically query my current process, the kernel object, and I can query the mitigation flags values. So these are the friendly names of all the mitigations you can enable for this mask right here. So you have something called export address filter, which protects exports on Windows. So you have a DLL which exports some functions. You have some of these other mitigations related to ROP. What this will do is inject a DLL called payload restrictions.dll into a given process to enable these. These are validated through hooking, user mode hooking. And then you have some other interesting ones. You have CET shadow stacks, which we talked about earlier. Extended control flow guard got deprecated, which was the next iteration of control flow guard, which was really awesome. Like I have a blog on this when this was an insider preview. I was so bullish on this. I'm like, this is going to be the best thing ever. But some stuff happened, and it got deprecated. And what's cool is you have these audit modes. So Windows will actually emit what's called an event tracing for Windows, or ETW event, when some of these mitigations are violated. So, if
did someone say ETW?
That's all you, Johnny. ET
Yes.
dubs.
And you have more of these too. So you have mitigation flags values as well. These are some of the OG mitigations. So Win32k is a very rampant place for vulnerabilities. Anyone that's been in the space before, right? So what's the mitigation? How do you defend against this? Well, it's simple. You just disallow the process from making a Win32k system call in the first place. You can't beat them, join them, so to speak. So just don't even let them execute in the first place, and whatnot. So I won't go into all these, but this is how that gets tracked. And so what happens is a given process, if it has the mask set for pointer auth user IP, which stands for pointer authentication for user mode instruction pointers, for again the code which we talked about earlier. This represents the currently executing instruction. Then the process gets updated with a key. So what I think is cool about Winbag is these link queries as an example. So what I can do is I can go for my current session, show me all of the processes where, let me hide this real fast. Mitigation flags to values dot pointer auth user IP is 1. So it shows me a list of all the names that have this mitigation enabled, which is super useful, especially for exploitation, debugging, and whatnot. And you can also do it in this pretty graph where you can select the state of pointer auth for all these processes as well. These are the PIDs. So as I mentioned, for pointer auth, when you create a process, if you're going to opt into pointer authentication, each process has its own signing key. So that's another thing as well. There's not one shared signing key for all the processes. Every process has its own signing key. So we can, again, do this. We can go for the current session, processes, where p.kernel mitigation flags to values dot pointer auth user IP is 1. I want to select the pointer auth key. So in this case, pointer authentication keys are actually 128 bits. So what we can do is we can do first, which gives us the upper, or we could do last, which gives us the lower. So to make this look even prettier, there is a way to create our own custom data structure. So we use this new keyword. And we can do pointer auth key low equals first. And we can display this as a graph. So we have our own data called pointer auth key low. We could add high if we want as well. So we do pointer auth key high equals the same thing here. But we do last. So we have the pointer auth key, and then we can also add in, to make this easier, name. So we have the name of the process equals p.name. So here's a list of all the processes and their pointer authentication keys as an example. You can do this for a bunch of different stuff in Windbag. I highly recommend this. My friend Jordan Shafir has 2 blogs called Windbag, The Hard Way, Part 1 and Part 2. And it shows a lot of these. DX stands for the debugger data model. You can do a lot of powerful queries. This is especially useful for crash dumps, for exploitation. You can do a lot of things like, I can display, I guess I can't because I'm in a local debugger. But one thing that I recently posted on Twitter is you could say, show me all of for the current call stack, show me all the frames which have this module involved. So anyways, that's how you view all of the keys. And so they get generated and they get stored. And anytime code executes in that process and a given module is compiled with pack support, that is what is used. Now, everyone's probably, well, maybe you're not thinking, what about kernel mode? Kernel mode runs into that conundrum we talked about earlier. What about signing kernel mode addresses? There's one shared kernel mode pack key, which is managed by Windows. And this is where secure kernel comes into play. So this is the secure kernel.exe binary right now. So let me increase the font on here a little bit. So the secure kernel has this concept of intercepts. Intercepts basically is a way for the secure kernel to tell the hypervisor, hey, I'm very interested in these operations. So for all of the hackers out there that have developed rootkits or anything like that, a common technique is I'm going to corrupt the MSR that has the system call handler present, and I'm going to insert my own system call handler. So anytime a system call is invoked, I get called, not the legit, handler. Well, you have to corrupt an MSR for that. MSRs are protected under the secure kernel intercept. So if you try to corrupt any of these registers, these MSRs, you're going to crash your machine. So one of the things that the secure kernel does is it installs an intercept on our machines for pack. These abstract numbers right here are basically the representations for the registers, which are stored by the system registers on ARM systems with those signing keys, which we talked about. So at any given one time, you can only have one signing key loaded on the OS. That's why each process maintains its signing key so that when that process is scheduled, has a thread scheduled on the processor, it will load in that new value. Same with the kernel as well. So if you try to corrupt the system registers in kernel to insert your own signing key, so hey, we want to sign our own return addresses or whatever, you're going to crash your machine as well. So that's one of the interesting things that I wanted to call out, which I called out in my blog too, is that secure kernel, again, this is the benefit of breaking out the OS and using the hypervisor. We can add additional protection, whereas before, what's stopping a kernel mode attacker from just inserting their own signing key or corrupting the latest return address or anything like that? So I will stop sharing my screen. I've been yapping for a while now. But
Cutter, you crushed it. That was amazing. That was awesome.
yeah, very interesting. Very interesting space to be in as well. ARM especially, but yeah, WinBag, very powerful tool. Very powerful tool that a lot of people, have basic understanding of it. But this new debugger data model, you can load your own JavaScripts as an example, your own scripts. You can load your own extension DLLs. You can do a bunch of interesting stuff that makes dynamic analysis a lot easier.
I like how you were just like writing WinDebug commands in there, like faster than most people write PowerShell commands.
If I act like that's some feat, if you saw how many times I've run this again, it goes back to the whole AI thing. I like how my fingers feel typing. Like I have a hard time giving up control. Probably a weird sensory issue for me. Yeah, so I've just done it so many times that, it's just kind of second nature, because I refuse to give up control in that regard. But
Yeah.
like you said, it's powerful. There's a lot of stuff that you can do. Like you can have conditional breakpoints, right? Like if you're someone that's in a debugger and you're constantly like, okay, there's this really hot code path. I'm going to set a breakpoint on this function, but I wish I could only hit this breakpoint if the first parameter was null. As an example, it's like, I have to manually go through. You can set conditional breakpoints in WinBag that say only break on this function if the first parameter is null, or only break on this function if the current process is, explore.exe as an example. So very powerful.
Yeah. I think conditional breakpoints have been the saving grace many times for me when I'm looking into something, because it's like I don't want to hit it every single time, and it's like I didn't even get to execute my code yet.
Yeah, if you're like in a system, not system call, but like, any kind of filtering network file or anything like that, that is a very hot code path. And so you're going to need conditional breakpoints I guess legacy endis or anything like that.
Yep. Some people were asking what your tweetors were, or your X, I guess is what it's called now.
Yeah.
Is that okay? You're Sharon? No. Yeah. Everyone was loving it. They were like, what's Connor's YouTube channel? I want to see him on the internet. So, dude, you're a wizard.
No, and that's the blog that I have pinned at the top, which goes over a lot of the ARM64 internals of interrupts. Because again, this is what's interesting in looking in this stuff. All these things are platform specific. Hypervisors, how you do interrupts, how you do system calls, how you do, context switches, all this stuff. And so I'm really interested in ARM on Windows because it's such a greenfield. So that's like interrupts, how it works, how the secure kernel and Hyper-V can assert interrupts into VTL0, a bunch of random stuff.
Very cool. So for those who have not read that, I highly recommend. Connor also does a really good job of, explaining things really in depth. So you'll often see like his blogs are very, very, very long, but that's because he goes through every little aspect. So it might be a longer read, but however, like he does go through them in very much detail. So at the end of it, you do feel like you understand it pretty well. So highly, highly, highly recommend reading that.
Can I say you were just on Steven Sims, right? The Off by One show where you had a long form demo, right? Even more so, kind of falling down the cliff even more than this.
We did 2.5 hours of basically I have a project on GitHub. It's called SK Bridge, and it's that VTL0 to VTL1 communication we talked about. It can manually you can invoke your own what's called secure calls, basically. And so I was just demoing how that works, how the process of transitions from executing context of one VTL to another VTL, and like how you make your own secure calls. But more commonly than that, a lot of reverse engineering is pattern recognition, right? Everyone knows that. John, I know you know that. Johnny and John know that from anything you've done. It's pattern recognition. Now, you do it enough, you can start to recognize, these bytes in memory, I know that that's a process object, just random stuff like that. But pattern matching in terms of here's the common patterns NT uses to talk to the secure kernel. And what I've done in that project basically is what I think is the most useful part is all those common patterns are encapsulated in options that you can specify. So you don't have to constantly recompile a driver to issue the secure call. You have a user mode client, which has these parameter transformation arguments that you can say, turn this address into a physical address when you make the call, or encapsulate this parameter as an MDL, or get me the secure process handle, which is another thing that we haven't, you could go on hours about. So there's secure objects and whatnot in the secure kernel. So that's the most useful part. But yeah, we went through it and just did all that stuff.
Very cool. So
2.5 hours though, so I don't expect anyone to watch it. I told Steve, I'm like, oh, it's gonna be an hour. It's gonna be an hour, no problem. Like I don't have that much. And then like next thing I know, I'm like, my voice is kind of scratchy. I'm like, oh man, it's been 2.5 hours.
It's like a cyber demo version of the Joe Rogan podcast, but with Connor. You just go on there and just go in hardcore in the paint. Well, this was awesome, Connor. I really appreciate the deep dives here. I'm sure the audience does as well. I mean, it's been awesome having you. Plan on having you some more in the future. John, did you have any questions, comments?
No, genuinely just so cool, dude. You know I love hanging out with you, Connor. I mean, I hope you did we scare you away? Are you willing to do this thing again? Can we?
Oh yeah, absolutely. I love just chatting about this stuff, and I really like hanging out with you all as well. Like I said, we had a lot of fun in Black Hat, I think, and
absolutely.
It's always I get such nostalgia too, because John, you remember how it was in AWE, like just those long days, and it's really fun, and so I enjoy hanging out. Would love to do it again, and yeah, it's been great. So thank you both for having
absolutely. Me. No, thank you, man. You taught me a bunch tonight, so I have a bunch of research to go back and do and learn now. So I appreciate that.
Thank you.
What do you think, Johnny? Is that a wrap for the old Payload podcast number 2?
I think so. I think now that we got 2 in us, 3 is going to be easier. I think right now our cadence is of bi-weekly. We might kick that up. Would people be interested in us kicking that up? Have you guys been enjoying this? Do you guys want us to stop? Yeah.
We still got to get like an actual account, so it's not just on John. I feel bad. Like, all right, Johnny, good news. We're still not on our own Payload podcast account.
We will be one day though, and we'll have shirts and merch, and it'll be sick. But
what is the merch going to say? Is it just going to be like the acronym, the letters, oh. Dang.
I know. We can't just have the acronym. We probably gotta spell it out.
Cool.
But we'll have to come up with something cool that's maybe not AI generated, because I keep trying to do these pictures and they aren't always coming out good. So
yeah, you keep asking me, can you remove the Nano Banana logo in the bottom right? Can you take Gemini out of the picture?
Yes, please. Yes, please. Yes, please. Yep. I sometimes I get so obsessed too, because I did Connor's picture and it's like it just wasn't cooking the way. And then I realized that like the majority of the time I was doing it, it wasn't in pro mode. And I was like, oh, dude, you gotta be kidding me.
Just feed more tokens. That's it.
Real token hungry.
That's the best business design ever. Pay via tokens.
Yeah.
Well, for real, cool. Thank you so much, Connor. Yeah, this was super cool. I know it's kind of a late evening for all of us, but it was still a lot of fun. And we'll have to do it again super duper soon. So
absolutely.
It's been a pleasure. Thank you, guys.
Absolutely.
Goodbye, Internet. I'm going to shut down the old live stream.
Goodbye.
But we'll catch you at the next one.